In this video, we will use the substitution method. Use the substitution method to solve for a missing letter or variable. This variable result will be a complex number. So in each of these examples or in each of these problems, you will be given two equations. One equation will contain two variables, C and D, and the other equation will contain a complex number. And remember that complex numbers look similar to 3 plus 4i. There's a real component and an imaginary component to a complex number. To solve, we will substitute the complex number into the variable c in the other equation. Then we will solve for the letter D. Let's take a look at a few examples. If c minus d equals 9 and c is equal to 4 plus 7i, what is d? So the substitution rule says that anytime that we see a c in this original equation, I would like to change it from the letter c to what c is equivalent to, this complex number. So let's go ahead and make that substitution and rewrite the problem. I now have 4 plus 7i minus d is equal to 9. Now for me, to solve for d, I recognize that it would be easier to move the value of d to the right by adding it to both sides. And that leaves us with 4 plus 7i equals 9 plus d. Now to isolate d, and hence solve for d, we can subtract 9 from both sides of the equation. This will leave us with d by itself, which is our goal. This is what we wanted. And we would combine like terms on the left-hand side. Since 9 is a real number, we would subtract 9 from the real number 4. 4 minus 9 is negative 5. The imaginary component remains unchanged, and we have negative 5 plus 7i is equal to d. Let's try number 2. If c plus d equals 4 and c equals 5 minus 3i, what is d? Well, let's first make that substitution. We'll change the letter c to 5 minus 3i. In this case, d is already positive, so I don't want to move it. Instead, I will move these two terms. And because addition is associative, we could actually eliminate those parentheses here, and it makes it easy to see that we could subtract 5 to eliminate the 5, so we'll subtract 5 from both sides. And we can also add 3i at the same time to both sides of the equation. That's going to get these two pieces to cancel, and we'll be left with d by itself. Now the real number parts can combine with real numbers, so 4 minus 5 is negative 1. And there was no imaginary component over here. 0i is what we had if the number was unwritten. So 0i plus 3i is 3i. If I had nothing and add 3i to it, that leaves me with 3i as well. So d in this case is negative 1 plus 3i. In example 3, c minus d is equal to 6. c is equal to 8 minus 10i. What is d? I suggest that you pause the video at this point and come back in a moment to check your answer. By adding d to both sides of the equation to move it to the right side, then subtracting 6 from both sides of the equation, we obtain the result for d, and that is equal to 2 minus 10i. Try number 4 as well. In essentially one step, we found that d is equal to negative 1 minus 5i. We subtracted 3 from both sides of the equation to achieve that cancelization, and we also subtracted 5i from both sides of the equation to achieve this cancelization. We're left with d by itself equal to negative 1 minus 5i.